Okay, good morning, everybody. My name is Kevin Dennis. I'm with Method Test Prep. I am actually the director of Long Island classes. Welcome again to Test Prep time, 11 o'clock, 11 a.m. Eastern Time, every Monday through Friday. We just talk about a couple of quick strategies with regards to things you can use on both the SAT and the ACT. Today, what I'm going to be talking about are solutions. You're actually going to literally see this word on solutions, the word solutions in a lot of math questions. And it's really important to understand what that means. So when they're looking for a solution, they're not necessarily looking for, hey, what is the answer to the question? What they're actually referring to is basically how often lines intersect. So that's what we're going to start with today. But before I get to that, again, I just do want to mention that a lot of the topics that we're going to talk about are ones that we can do through online tutoring. We do tutoring for both the SAT and the ACT and any subject that's out there. If you are interested, you can simply just go to the link that you see there, www.methodtestprep.com/online-tutoring. Okay, so again, let's now talk about solutions. So what does solutions mean? So solutions mean is basically how often straight lines are going to intersect. Okay, it may not necessarily be straight lines, so the bottom right one says, but we're going to focus on straight lines for today. But what I want to talk about right now is like if you see solutions, when that says zero solutions. So again, when we talk about how often they intersect. So if I say zero solutions, that means they never intersect. And important to understand is that because they never intersect, we know that those lines are parallel. Because they're parallel, we know that they must have the same slope, and it's also key to know that they're going to have a different y-intercept. So when we look at y equals mx plus b format, the slope is the same, the m is the same, the b is going to be different. Sometimes you're going to talk about one time when there's one solution. So if there's one solution, again, they're talking about intersections. So how often they intersect, so they're going to intersect once. The key with solving that question is to understand that we're going to set those lines equal to one another. Sometimes you're going to see infinite solutions. So whereas with zero solutions, we know that they never intersect, so we know they're parallel. If there's infinite solutions, that means it must be the same line. So it's the same line, the same formula. That means both the y-intercept and the slope will actually be the same. So not just the slope, also the y-intercept. So both m and b in y equals mx plus b format will be the same. Occasionally, they're just going to talk about how often lines intersect, or there be plane curves, such as parabolas or cubits or other formulas. Sometimes there's a graph. So basically, if it's greater than 1 but less than infinite, then they're just talking about how often the lines are going to be intersecting with parabolas, cubits, or some other form. I'm going to be focusing on just two of these today. I'm just going to be focusing on one problem of each, with zero, where they never intersect, and then also when they never intersect, and then infinite, okay, where they're going to be again the same line, the same slope, and the same y-intercept. So the first problem I'm going to talk about here, as we look at it, we see a formula that says kx minus 3y is equal to 4. And then it says 4x minus 5y is equal to 7. So the question that's involved, it says in the system of equations above, k is a constant. And what they mean by constant is that it just stays the same. K is a constant, and that x and y are going to be variables, so those numbers change. So for what value of k will the system of equations have no solution? So I've bolded the question and I've underlined the essential thing that we should be looking for. We should be looking for, again, no solution. So again, what does that mean when it says no solution? Okay, that means they never intersect. That means they're parallel. That means the slopes are going to be the same. So the key here with a question like this is I need to set those slopes equal to each other. So the next thing I'm going to do is I'm going to break up these two lines. So I'm going to set them side to side. And I'm going to go ahead and try and solve these questions. And what I want to do is the first thing, as with most lines, need to get them into y equals mx plus b format. So I'm going to start with my two formulas. I have kx minus 3y is equal to 4. And then I have 4x minus 5y is equal to 7. So let me start with the one on the left. Again, I need to get into y equals mx plus b format. So now this is where my algebra is going to come into play. Because what I need to do is I need to get that y by itself. So the way I'm going to get that y by itself, because it's buried, I need to get it alone. The first thing I want to do is I want to subtract the kx over. Okay, so I'm going to get everything away from that y. So by subtracting the kx over, I'm going to end up with, I'm going to cancel out those kx's, and I'm going to end up with negative 3y is equal to negative kx plus 4. Now again, I still need to get this into y equals mx plus b format. So again, I need to get that y by itself. So since the negative 3 is being multiplied by the y, as with everything for the algebra, I want to do the opposite, and I'm going to divide. So I'm going to divide by negative 3 on both sides. And again, that's now going to get me into my y equals mx plus b format. So it's going to end up being, and it's going to look a little weird, but it's going to end up being y is equal to k over 3x minus 4/3. So the negative 3 is going to cancel out with the negative k, so those negatives are going to cancel out, so that's why it becomes positive k over 3. The positive 4 is going to be divided by the negative 3, so it's going to end up being negative 4/3. So that's the key thing to understand here is when you do divide into terms that are being added or subtracted, you must divide into every single term. Okay, so that's something to always keep in mind. Now, let's take a look. We're going to take it from there. So since, again, I need it in y equals mx plus b format, I need to focus on what's before the x. What is being multiplied by the x, by that variable, the x coordinate in this case. So in this case, what's being multiplied by the x is going to be the k over 3, that k thirds. So this case, on my left formula, m, or the slope, is going to be equal to k over 3. And yes, it looks weird. We have a variable. The ACT love doing questions like this. If you get some weird stuff, hey, that's normal. It does happen. So here, so the slope on the left, we now know is equal to k over 3. So now let's take a look at our next one. So again, same thing. I need to get that y by itself. This one's going to be a little bit simpler because we don't have that variable there to confuse us. So I'm going to, again, start with my any addition and subtraction. I will subtract the 4x over. And what I'll end up with now is negative 5y is equal to negative 4x plus 7. And I'm doing the exact same thing like I did with the one on the left. I want to make sure I keep it in the y equals mx plus b format. It might be easier just to do 7 minus 4x. Certainly sometimes that works better with the algebra. But in this case, again, I need an y equals mx plus b format. So again, I want to keep it with the x to the left and then the constant, the 7 on the right. So again, the next step, I still need to get that y by itself. I'm going to do the opposite of multiplication, which is division. So I'm going to divide by negative 5 on both sides. Since I'm dividing by negative 5 on both sides, again, I need to divide into each term on the right because there's addition and subtraction. So if I divide by negative 5 on both sides, the one on the right, so I'm going to get y is equal to negative 4 over 5x minus 7/5. Okay, so again, I'm dividing into each term. So I've got negative 4 divided by 5, so that stays negative. That becomes negative 4 over 5. Since I'm dividing by negative 5, that becomes minus 7/5. I could leave it as positive negative 7/5. That would be the same thing. I'm going to make it a little bit simpler. So it's minus 7/5. Again, I need to keep it in y equals mx plus b format. That's the whole reason why I'm doing this. So again, I need to identify the slope. Again, so what's being multiplied by the x is going to be the negative 4/5. So the slope on the right equation is going to be negative 4/5. So again, the one on the left, I have a slope of k over 3. The slope on the right, I have a slope of negative 4 over 5. So the key thing I need to now do is I need to now set those two equal to each other. It's the whole reason I'm doing this in the first place. So the one on the left is k over 3. I'm going to set that equal to the one on the right, which is negative 4 over 5. And now we're going back to some basic algebra here. So if I have two fractions, they're on opposite sides of an equal sign. I want to make sure that's clear. I've had some students get a little confused. They're opposite sides of an equal sign. That's when we're going to cross multiply and solve. Okay. Sometimes I've had students with fractions they're adding or subtracting. They're so used to cross multiplying that they want to do it all the time. But again, it's only when it's on opposite sides of the equal sign. So in this case, so we're on opposite sides of the equal sign. I'm going to do negative 4 times 3 is equal to 5 times k. So in that instance, I'm going to then do negative 4 times 3, find out that negative 12 is equal to 5k. And then just like the algebra I did a little bit earlier, I'm trying to solve for k. That's ultimately what the question is asking for. I'm going to solve for k, so I want to get that k by itself. Since 5 is being multiplied by the k, I'm going to divide by 5 on both sides. And then once I do that, I'm going to find out that k is simply going to be equal to negative 12 divided by 5. So again, simply understand the keys, again, that the slopes are the same. I need to set the slopes equal to each other. And then once I do that, then I can go ahead and solve for my question. Okay, I'm going to hit one more example. So in the previous example, we focused on how it was no solution. The one we're going to focus on now is where there's an infinite amount of solutions. So again, infinite amount of solutions is going to be the same line. It's going to be the same formula. Okay, so both the slope and the y-intercept are going to be the same. So in this particular question, okay, we have the example 2. So I have ax plus by is equal to 12, and I have 2x plus 8y is equal to 60. So a and b, again, are constants. Those are numbers that don't change. We have an infinite amount of solutions, so that's what I've underlined to make sure that we know that that's what we're looking for. And again, we're looking specifically for what a over b is. So we don't need to solve individually for a or individually for b. I just need to find the relationship or the ratio of a over b. So again, I'm going to break up my two lines. Okay, so again, were my two formulas, and I have ax plus by is equal to 12, and I have 2x plus 8y is equal to 60. So the one on the left, so again, everything has to be equal to the same here. So whereas the other ones, I could just focus on the y, I could just focus on the slope. The y-intercept was actually irrelevant to the question. It's important to solve for it. Make sure you're following all your steps, because if you know you're following every single step, even if it doesn't turn out it's really going to matter, you're more likely to get everything right. So in this case, since we know that they're both equal to each other, so I need to find some sort of relationship where they're equal to each other. So what I could do is the one on the right is I could set the one right on the right equal to 12 by dividing by 5. I would say most students are probably just going to multiply by 5, because once I get those two solutions equal to 60, then I know that everything is going to be the same. All right, now again, sometimes these questions just look weird. Don't let them confuse you. Just do everything that you're used to doing. Just follow the steps that you're normally going to do, and you're going to get the right answer, no matter how weird they're going to be. So since I want to set them both equal to the same value, in this case I'll set them equal to 60. So the one on the left, the way I'm going to do that is going to multiply it by 5. Please be very careful, ladies and gentlemen, when you distribute. When I've done classes in tutoring and teaching and everything, I would say by far the number one error I've ever seen on this exam is our distribution errors. So please be very, very careful anytime you distribute. And again, just like when we divided into every term, because it was addition or subtraction, same thing with multiplication. You got to multiply, you multiply to every term. And also, anything you do on one side of the equation, you must do the exact same thing on the other side of the equation. So now that I've distributed the 5 to all three terms, the ax, the by, and the 12, I'm now going to focus on my a's and my b's. So if I notice, on the left, we see 5a is before the x, and on the right, the 2 is before the x. Okay, now again, everything must be equal to each other. So I'm just going to focus on those coefficients. So I'll focus on the 5a before the x on the left equation. I'm going to focus on the 2 before the x on the right equation. So since, again, they must be equal, I know that 5a must be equal to 2. Since I know that 5a must be equal to 2, and I'm trying to solve for a, I'm then going to, again, same thing with algebra, always do the opposite. I'm going to divide by 5 on both sides. And if I divide by 5 on both sides, I'm going to find out that a is equal to 2 over 5. Okay, again, I know fractions really throw a lot of students off. Don't let them throw you off, ladies and gentlemen. Get a equals 2/5 is what we're going to get. It's what you're going to see. You better get used to it. Okay, so now we're focused on a, but we're looking for the relationship between a and b, the ratio. What is a over b? So now let's focus on the b's. So just like I focused on the coefficient on the left, that 5a must be equal to 2, I'm going to do the same thing with the b's. So before the y on the left equation, I see 5b. Before the y on the right equation, I see 8. So I know that 5b must be equal to 8, just like I knew that 5a must be equal to 2. So again, I'm going to do the exact same thing like I did with the a's. I'm going to do the same thing with the b. So since 5a was equal to 2, and I divided by 5 on both sides to find that a is equal to 2/5, I'm going to do the same thing here. I'm going to divide by 5 on both sides to find what b is equal to 2. So I'll divide by 5 on the left side, I'll divide by 5 on the right side, I'm going to find that b is equal to 8/5. So the question is ultimately asking for what is a over b. I now know that a is 2 over 5. I know that b is 8 over 5. So now I know that a over b is simply going to be 2 over 5 divided by 8 over 5. Okay? Now, I'm not going to get into all the rules as far as fractions. That's probably going to be a test prep time that we're going to be doing in the future. A lot of these questions would be no calculator, ladies and gentlemen. So if this was a calculator question, I would certainly make sure you can, by all means, put it in the calculator. Just know that anytime you do fractions in a calculator, you have to do the numerator separately from the denominator. Either put the numerator and the denominator individually in parentheses, or solve for the numerator and then solve for the denominator and then divide it out. If you're also dividing fractions, you may remember keep, change, flip, may multiply by the reciprocal. For time reasons, I'm just going to show you one little quick shortcut here that you may remember. If you are dividing by fractions and the denominator of both fractions is the same, you can actually just cancel those out. And if you think of multiply by the reciprocal or keep, change, flip, you're basically canceling out the denominator on one with the numerator on the other. So since I know that I'm canceling out those 5s, that means I know that a over b is going to be equal to 2 over 8. Since a over b is equal to 2 over 8, you could reduce that to 1 over 4 or 0.25. This actually is a question that on the SAT would be a student-produced response question, so please make sure that you put it in. It would not matter if you put it in as 1/4 or 0.25. Either would be acceptable. I'm just going to mention a couple other quick ones real quick. We just don't have time for, but again, we talked about when there's more than one solution. So that's kind of the one we see here on the left. That's an instance where we have a straight line that's intersecting our parabola. So that and sometimes you're going to see an instance where you have two solutions, and how are you going to solve that? The one on the right focuses on where we have two straight lines. It doesn't use the word solution in this case, but that's effectively what they're looking for. So we know that the beef and the chicken are the same. So since we know the y's are the same and looking for when the x is the same, we're actually looking for when the chicken is the same. We know that we're looking for when these lines intersect. So in this case, like that'd be an instance where we would set those two lines equal to each other. Okay? So I did want to just talk about our Test Prep Time Plus. We do this every Monday through Friday at 1 p.m. These are extended, so these cost $10. The one that we're doing today is on passage comprehension strategies. It's actually a reading strategy. The one, if you found this was interesting, if you know that lines and coordinate geometry is not something that's one of your strengths and you think you want to do a little bit more on that, the next one that we are doing that involves coordinate geometry will be on April 20th. That's the linear equations with math, so that's on April 20th. Again, you can go ahead and register for that. I did want to just obviously talk about our self-paced program. Excellent opportunity right now. You pay for the program. Normally it's $199. This is $99.50. Again, our little tagline. We love to say that 15 minutes can improve your score. 15 minutes a day can improve your score. And that's, again, really important to kind of focus that with the SATs and the ACTs, when they're offered next, again, we do expect the June 6th SAT and the June 13th ACT to run at this point. Anything can change. But it's not something you want to cram for beforehand. So that's why the online self-paced program is so beneficial. Because again, you can focus on week by week, really time it out leading into those exams. Definitely subscribe to our blog. We have webinars, a lot of information as far as the SAT, the ACT, college entrance exams in general. A really good way of keeping informed, both on Facebook, Instagram, LinkedIn, or Twitter. Again, that's it for today. I hope you picked up a couple of quick tricks. Again, it's just a quick way of learning a couple things when you see solutions and really, again, what they're looking for. Have a wonderful day.